Welcome to a webcast produced by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Algebra series and concerns completing the square. This guide describes the algebraic technique of completing the square and shows how to use it to solve quadratic equations. Introduction. Completing the square is a more advanced algebraic technique which is extremely useful in solving quadratic equations and also plays a part in strategies for solving more complex mathematical problems. It is also used to derive the quadratic formula. See study guide, Solving Quadratic Equations Using the Quadratic Formula. A good understanding of this study guide relies on many algebraic techniques described in other Steps into Algebra study guides. If you read through this sheet and understand a majority of the manipulations and arguments involved, then you may consider yourself to be proficient at algebra. If you find sections difficult to understand, return to those areas and read the relevant study guide. The method. The method of completing the square is best explained by using an example. Here it is. Solve 3x squared plus 12x minus 5 equals 0. Every quadratic equation contains either the mathematics x plus n all squared or x minus n all squared concealed within it. The bracketed expressions are the squares of completing the square, and the value of n is determined by the particular quadratic equation you are investigating. The first stage of completing the square is to identify x plus n all squared or x minus n all squared within the quadratic equation you are solving. The task of finding either x plus n all squared or x minus n all squared is made simpler by rearranging your quadratic equation to the form x squared plus bx plus c equals 0 if it is not in this form already. The example is solve 3x squared plus 12x minus 5 equals 0, which is not of the form x squared plus bx plus c equals 0, as the coefficient of x squared is 3 and not 1 as required. Part of the first stage of completing the square is to divide the quadratic equation by the coefficient of x squared unless the coefficient is 1. In this case the coefficient is 3, and so after dividing 3x squared plus 12x minus 5 equals 0 by 3, you get x squared plus 4x minus 5 over 3 equals 0, which is now of the form x squared plus bx plus c equals 0, with b equal plus 4 and c equal minus 5 over 3. Returning to x plus n all squared and x minus n all squared, if you expand the brackets you get x plus n all squared equals x squared plus 2nx plus n squared, and x minus n all squared equals x squared minus 2nx plus n squared, which are both quadratic expressions of the form x squared plus bx plus c, with b equal to plus 2n in the first expansion and b equal to minus 2n in the second expansion. The value of b in the quadratic equation you are solving determines which of the two squares to use. If b is positive, you use x plus n all squared, and b is negative, you use x minus n all squared. In this example, b equals plus 4, and so you choose x plus n all squared. You now need to calculate n. As b equals plus 2n, which equals plus 4, it follows that n equals plus 2. In fact, the value of n is always half of b. You can use the value of n to find that the square in this specific question is x plus 2 all squared. However, be careful. You are not saying that x squared plus 4x minus 5 over 3 equals x plus 2 all squared. merely that x squared plus 4x minus 5 over 3 contains x plus 2 all squared. The next step is to adjust your mathematics to account for the difference between the quadratic equation you are solving and the square you have identified. In this example, you have the square x plus 2 squared equals x squared plus 4x plus 4. But the expression in question is x squared plus 4x minus 5 over 3. As you can see, the first two terms, x squared and 4x, are correct, but the constant minus 5 over 3 is incorrect. To correct this, add and subtract the constant generated by expanding the square, in this case 4, to the expression in question. You can change the order of the terms to identify the square, bracketed in the mathematics below. So start with your expression x squared plus 4x minus 5 over 3, and then add and subtract the 4 generated from expanding the square. Now reorder the terms to give the square x squared plus 4x plus 4. Finally, write the bracketed term as the actual square, x plus 2 squared, and combine the minus 4 and the minus 5 over 3 to give minus 17 over 3. In other words, you have written the quadratic expression as the square and an extra constant term. This is what completing the square is. You have identified a squared term in a quadratic and completed it by adjusting the constant. But why should you do this? In its original form, a quadratic equation cannot be solved by algebraic manipulation, but after completing the square it can. Returning to the example, after completing the square you find that x plus 2 all squared minus 17 over 3 equals 0. Now, adding 17 over 3 to each side, you find x plus 2 all squared equals 17 over 3. Now, taking the square root gives x plus 2 equals plus or minus the square root of 17 over 3. Then, subtracting 2, x equals plus or minus the square root of 17 over 3, all subtract 2. Here's an algorithm for completing the square. 1. Divide the quadratic equation by the coefficient of x squared. 2. Use the coefficient of x to choose the correct square, either x plus n squared or x minus n squared. 3. Halve the value of the coefficient of x to find n. 4. Expand the square to find the constant. 5. Adjust the constant to match the quadratic expression in the question. 6. Solve for x. Derivation of the quadratic formula. The famous quadratic formula for solving quadratic equations is derived by applying the completing the square method to the general quadratic equation ax squared plus bx plus c equals 0. Step 1. Divide by a to give x squared plus b over a times x plus c over a equals 0. Step 2. Choose x plus n all squared. Step 3. Halve the coefficient of x. Here the coefficient of x is b over a, and so n equals b over 2a. Step 4. The square is x plus b over 2a all squared, which equals x squared plus b over a times x plus b squared over 4a squared after expansion. Step 5. Adding and subtracting the constant b squared over 4a squared to and from x squared plus b over a times x plus c over a gives the appropriate balance. Starting with x squared plus b over a times x plus c over a, you add and subtract the constant b squared divided by 4a squared. Then rewrite to identify the square, which is shown here in brackets. Now write the square as x plus b over 2a all squared. And finally combine the constant terms to give x plus b over 2a all squared plus 4ac minus b squared all divided by 4a squared. Step 6. Solve for x. You start with the result from step 5 and set it equal to 0. So x plus b over 2a all squared plus 4ac minus b squared all divided by 4a squared equals 0. First, subtract the constant 4ac minus b squared all divided by 4a squared from each side. This gives x plus b over 2a all squared equals b squared minus 4ac all divided by 4a squared. Next, take the square root of both sides, which gives x plus b over 2a equals plus or minus the square root of b squared minus 4ac all divided by 2a. Then subtract b divided by 2a from each side, which gives x equals plus or minus the square root of b squared minus 4ac all divided by 2a minus b over 2a. And finally combine the algebraic fractions, which results in the well-known quadratic formula. Further guidance and information. If you have any further questions about algebra or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor, or make an appointment to see a learning enhancement tutor in the Dean of Students office. You can telephone 01603 592761, email dos.help@uea.ac.uk, or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills. This guidance is one of a series on mathematics produced by the Dean of Students office at the University of East Anglia.